Okay, but in many cases, it's the ground where the current is flowing, and therefore it makes sense to measure the electromagnetic emission that is generated by the whole switching activity, crowbar current, dynamic switching current, somewhere at the ground pin. And this is exactly what the idea is behind the so-called 1 ohm method, because they were placing a 1 ohm resistance as a shunt resistor and measuring the voltage drop across this resistor to characterize the electromagnetic emission. Okay, the standard IC 61967-4 defines the 1 ohm and the 150 ohm method. If there is just one ground pin, then usually you're placing the current probe or this 1 ohm resistor between the ground pin and your ground plane, which is actually a signal return plane in this case. And then you're measuring here the voltage drop. If you have multiple ground pins, for example, a digital ground pin, an analog ground pin, then the standard recommends to make a small ground plane, so whatever is called IC ground plane, connect all the ground pins to this ground plane, and then from this ground plane, connect it to the reference plane on your printed circuit board so that all the currents are summarizing then somewhere here, and then here you're placing this current probe. Okay. Yeah, this is then the way how such a current probe looks like. There is a commercial one available. And here you can see the 1 ohm resistor. And then you have a matching, or you need a matching to match the 50 ohm input impedance of your EMI receiver. And the matching in this case is pretty simple because you have 1 ohm here, 50 ohm there. You just need then 49 ohm as series resistance connected then to a coaxial cable, for example, then here, where you can then go directly into the input of your EMI receiver. Yeah, the frequency range is pretty big, goes from more or less DC to 1 gigahertz. The prerequisite is that you have a very stable 1 ohm resistor. Also the simple SMD metal film resistor, where you can then in the lab try out what is the impedance of this resistor at 1 gigahertz. I'm pretty sure it's not 1 ohm anymore. So don't use just one resistor. Use a resistor which really has 1 ohm all over the frequency range. I think it would be hard to find one. And this is also a drawback because the standard doesn't really, as far as I know the version of the standard, maybe they have changed it a little bit, the standard doesn't really define what kind of resistor you should use, so which is the best one. It only says, plus minus 1%, 1 ohm. But what's written in the data sheet is plus minus something for the DC value of the resistor, and not for the value at 1 gigahertz. So make sure to place a resistor which has plus minus 1% at 1 gigahertz. Might be tricky to find one. Okay, maybe this is also the reason why the 1 ohm measurement technique is not that often used.